Hello friends, good day from Skills to Update. In this tutorial, we will going to learn the basic concept of object-oriented programming. So let's start with a brief overview of the programming. So what is a computer program? A computer program is a set of instructions for a computer to solve a specific problem, like we write a code to add two numbers, and the program execute on computers, and as an output we can get the addition of the two numbers. This is one example of very simple computer program would be. Now there are three types of programming language, and one is first is the machine language, and then assembly language, and then high level language. So now we'll see what are the machine, assembly, and high level language is. So machine language is a native computer language and only understandable by computer. It consists of 1 and 0 only, like binary digits. So since it consists of 1 and 0, we cannot write a machine language program. Now the next step of language is assembly language. Assembly language is also known as a low-level programming language designed for specific type of processor, in kind of a processor programming. Assembly language is eventually converted to a machine language when it's executed. There is some example of, assembly language like adding two numbers. And finally, it's a high-level language. A high-level language is, today's world language. It's a easy write computer programming language based on the English syntax. All modern-day language like C, C++, Java, Python, they are all high-level language. And high-level language also finally converted to assembly language, and eventually it's converted to machine language when it's executed on a computer. So example, here is a short example of how we can write two numbers. So we have declared the two numbers and finally the result. This is a syntax of adding two numbers. So two main programming approach in high-level language is procedural programming and object-oriented programming. Old programming languages are procedural programming. If you look at the language in 1960s or 1970s or even 1980s, then you will find lots of procedural languages. Some very popular procedural language example are C, Fortran, COBOL, Pascal, and in today's world you hardly find these languages are used. They're kind of a dying language. But we'll learn some concept of the procedural language. A procedural programming language is based on the concept of procedure. The procedure, also known as routine, subroutine, functions, or methods, even methods. A procedure is nothing but a block of code to perform a particular task. In a procedural language, a programming goal is achieved through a set of procedure call, and procedure call executed step by step. So a program may have a various procedure, like procedure 1, which may call the procedure 2, and then procedure 2 may call the procedure 3, or procedure 3 may procedure 4. Or procedure 4 can call another procedure. So this way it is going to execute a step-by-step process, one procedure after another procedure this way. So it is also known as a top-down approach. But in today's world, and today most of the leading programming language, right, like Java, C#, Python, PHP, .NET, Scala, Ruby, Perl, are some example of the object-oriented programming language. So all the mainstream languages are object-oriented programming language. And object-oriented programming, or in short OOP, is based on the concept of object. An object is an unit having data and methods. So in an object, it encapsulates the data and methods as a unit. The method is similar to a procedure or function. Any real-life entity can be presented as an object in object-oriented programming. Let's look some example. Let us look at the bank account. Bank account may have like account number, holder name, account balance, or maybe many things like your date of birth, or your address, your personal details. But let us, for conceptual purpose, let us create a very simple bank account having an account ID, holder name, and account balance. These three properties known as state or data. And account balance can perform certain operation, like it can withdraw money or deposit money or even get the account details like your balance details, something. So these functions which are known as behavior or methods. In object-oriented programming, a set of objects calling each other methods to solve a problem. An object can interact with another object through a message. A message is nothing but calling the methods. Here you can see in object-oriented programming, all objects are interacting with each other through messaging to achieve a solving a problem. Here I have captured the summarized information between OOP, object-oriented, and procedural language. So the first thing is object-oriented programming. The key of object-oriented programming is the object. And while the procedural programming, the key is a procedure or routine. And in ops, a set of objects interacting together to solve a problem, and while in procedural, it executes a set of methods to solve a problem. Object-oriented programming is more secure because of abstraction and polymorphism we'll discuss later. And it also supports the data hiding or data protection, and this is where the power of object-oriented programming is. But in procedural programming, no proper support for data protection or hiding. And object-oriented programming based on the concept of object, and which provides more modular way of organizing the data, organizing the information. And hence it's less complex to write a object-oriented program, and it's easy to add a new data type or extend the functionality or adding the new function in object-oriented programming. Procedural programming comparatively less modular, and that's why it's more complex to write. And while we try to add the new data or function in procedural programming languages, it may impact the whole programs. So it is quite difficult. Now we are going to discuss about class and object. So class and object are the core building blocks of object-oriented programming. A class can be considered as a blueprint, template, or design from which the objects are created. Now let us look some real example. Let's say we have a car factory, and the car factory have decided to build a new model of car. To build a new model of car, first thing we have to do, we have to create a blueprint or design for that car. Once the blueprint is or design has been created, then based on that blueprint, we can create number of real car from in a car factory. Now the blueprint consider as a class. So this is not the actual car, but is a blueprint. So the blueprint of the car is actually class, and the original car which created in a car factory based on the blueprint, this original car can be considered as an object. So once we have a class, once we create the class, we can create multiple objects from that class. So class is actually the design of the logical thing, while the objects are actually the real world entity. Let us consider as a very simple person class. We design a person class which having only a name and age. In reality, it may have lots of other property, but a conceptual person class, let's say, only having name and age. Now, once we have created the person class, from this person class, we can create many real life person. Like here, John Doe is one person having age 24, and Peter Clark another person having age 36, and Tom Hanks having age 50. These all are real life person which are the object created based on the person class. Now each class defines a set of properties and method, also called the states and behavior, that each object can have. Now look at another real life object, a bank account. So a simple bank account can have a account ID, holder name, or account balance, and it can have an operation like withdraw money or deposit money or account details. So these are the states, and this withdraw money, deposit money are functions or behaviors. An object is actually an instance of a class having states and behavior and identity. Okay, the states of an object is the data of the object. The state of the object is the actual information held by the object. The state of the object can be changed through its behavior. The behavior are actually method or function that can change the state of the object. As we can see, we have having a bank account class, and from that bank account we create a many actual bank account. Like this is John Doe bank account who has a account balance of 12,000, while the Peter Clark having an account balance of 1,000, and here is the account of Tom Hanks. So these are the real life bank account having the real states, different states or data in the actual bank account object. So identity specify how one bank account is different from the other bank account. So, and another important thing that state of an object can be changed through its behavior, means data can be changed through methods. So here is a bank account of the John Doe. Now suppose we want to deposit 1,000 USD to John Doe bank account. So we call the deposit money method and deposit 1,000 USD. So the before the state of the object, I mean the account balance having 7,500 USD, but after the deposit method being executed, the account balance is changed to 8,500. So the states of this class has been changed through a method call. I hope you already got a fairly good idea about class and object. Now we look at the 4 key object-oriented principles, or these 4 principles known as the pillar of the object-oriented programming. And this 4 principles is abstraction, encapsulation, polymorphism, and inheritance. Now we look what the encapsulation is. Encapsulation is a data hiding or protection mechanism to prevent the direct modification of the object data. It mandates that data should only be accessed through its method or behavior. Now look some real life example. We have a bank account object, and bank account object having a field like account ID and account balance. And it has a method like the transfer money or deposit money. Now encapsulation say no one should directly able to access this data like account ID or account balance. But this data should be accessed through well-defined method like transfer money or deposit money. Now let's look at some bank transfer of money. So we have a 2 bank account object, bank account A and bank account B, and we are transferring the $100 from bank account A to bank account B. So it will reduce the bank account balance from 500 to 400, and it will increase the bank account balance after transaction from 800 to 900. So bank account balance will be 400. So this is by mistake, it will be actually 400. And bank account B having a new balance will be 900. So you can see we have transfer in an integrated way where the data consistency has been kept. So if we have a direct access to this account balance, someone can change the value. So someone can change the value from your 1,000 USD balance to 1 million USD, and that could be a disaster. So that's why I tell we should not directly access or modify the data, but through a well-defined logic, like this transfer money logic says that it will be reduced from account A and then increase the money of the account B. Encapsulation is achieved through various access modifiers like private, protected, or public with different level of data access. In short, the private modifier make the data private. That means if we declare the data as private, it should not be accessed from outside the class. And the methods or the behavior is kept as public, so it can be accessed outside the class. So this private and public or protected are the mechanism through which we achieve the encapsulation. Now next is the abstraction. Abstraction is a process of hiding complexity of the program from outside world and expose the program through well-defined and simple interfaces. Now look at some real-life example of abstraction. We know how to drive a car. A car is actually a very complex machine. But to drive a car, we just need to know how to operate the steering and how to change the gear and clutch, brake, accelerator, right? Knowing this, how to operate the steering and change the gear, is enough for driving a car. We don't need to know the internal machine mechanism, how the car is moving, or what happens when we move the steering to left and right, how the car moves, or how we change the gear, how the gear change and move the car faster, slower, or reverse direction. That mechanism we absolutely don't need to know. So the car drive through a defined interface like steering or clutch, accelerator, gear. So here is an real life example. Let's say we have built a weather service application which will provide the weather forecast data based on the latitude and longitude. So for a user to access our world weather service, they just need to know how to pass the latitude and longitude to our program. And they can call a web service or a method or passing through the UI. Means on the background, world weather service may first determine which latitude, longitude belongs to which country, and from that country it may remotely contact to that country weather office and get the data. It may contact to the US weather office for US weather data, or UK weather office, or India weather office, or China weather office. In background, it may do some very complex operation, but a user who is using the world weather service, they just need to know how to call a interface and pass the latitude and longitude to world weather service. So this is called the abstraction, and abstraction is achieved through something called interface. And next is the polymorphism. Polymorphism means one interface can take many forms. It will allow an interface or method behave differently for different situation. Now let us say we have a draw class and having a draw shape method. Now through polymorphism, this draw shape can draw a circle or a triangle or a rectangle or circle. So through polymorphism, the draw shape method may actually point to the different draw class, different class to draw a circle, triangle. So this will actually promote the code reusability. Otherwise, we need to write a different method for all this draw circle, draw triangle, or draw rectangle, square, or any shape. There we have to handle with a number of methods. But through polymorphism, draw shape method able to draw all these different shape. So the method overloading and method overriding are two important way to achieve the polymorphism in Java. Now last is the inheritance. It allows a class to call a child class to inherit the properties from another class called parent class. Now let's look some real life example. Let's look the bird family. The bird characteristical lay eggs, have beak, 2 wings and feather. These 4 are characteristic of a bird. Now look at a specific type of bird. The eagle, beside these 4 properties, can fly high, can hunt, and very fearless. So eagle has these 4 properties like legs, have beak, and wings, feather, plus it's fly high, can hunt, fearless. Similarly, the woodpecker has all these 4 properties, and it has its own property like its beak, wood, eat worm. Same can be said about the peacock. So all these 3 birds have this common bird characteristic plus their own property. So I can say all this eagle or woodpecker or peacock, they inherit the common bird properties from the bird class. So let's look some real life example or inheritance. We have a bank account class. So bank account class can have a to field like account ID or holder name. Now we may have a different type of bank account like saving account or credit card account or fixed deposit account. Now the saving account can have a balance or minimum balance required to maintain that saving account. But saving account also have an account ID or holder name. So credit card may have credit limit or an interest rate. But credit card also have account ID and holder. Same can be fixed deposits as a tenure and interest rate as well. So all these saving account have credit account and fixed account having the common characteristic of the bank class. So they have inherited the properties of their parent bank class. So thank you so much for watching our video to the end. I will request, if you like my video, please subscribe our channel and like the videos. It will help us to come up with a new video in future. Thank you.